All right, today in class we're going to talk about ways to measure angles in radians and degrees. So this first one is going to be brand new to you, and it's really our focus for today. And we're going to do this through an activity. So you were given all of the materials necessary. If you don't have a glue stick when it comes to that, you can just use tape, that's fine. But here, the instruction sheet is going to walk you through all the steps you need to complete. I'm going to give you a heads up right here. When you are at step 4 right here, when you cut your pipe cleaner to be the length of one radius, make sure you're as accurate as possible. Okay, that's going to make sure that when you go answer the questions throughout, that there's similar answers to what they're supposed to be based on that. So try to get as close as possible. So after you cut it, remeasure it and make sure that you are using wire to wire and knowing that length. Okay. From there, you're just going to go through all these instructions, and just like normal, at the end of the page, end of the front page, you'll come back to the video and I'll add some notes and talk about some questions. Okay. Pause the video and get started on that now. Okay, through your instructions, you should have had these labels around. Okay, we're marking every 90 degrees. So normally, when we measure an angle, we write that label inside, but it was wanting you to mark them around the circle. So this is going to be very similar to like what you saw on your geometer in geometry. Okay, so if you didn't have a geometer from that or a protractor of any sort, this angle for people in class somewhere ranged between 55 degrees and 60 degrees. So those are the different values that we could have gotten. And then everything else from there, hopefully you have marked already. Okay, because the measurements that you were going through here, you were just using that pipe cleaner to measure around all the way through to answer those questions. Okay, so somewhere around 55 to 60. And this thing has a special name. So what I want you to do on your circle is actually mark this off for me. Okay, so on the edge, this measurement where we took the length of our radius and just measured it out is defined as 1 radian. Okay, and 1 radian is approximately, we'll do the math to fill in that number. Okay, but the definition is just the length of the radius. What angle would that mark off when we talk about a central angle of a circle? Okay, so going through some of these, the length of the arc, because we are dealing with a central circle, it's going to be equal to the radius, and yours may be different. So I didn't write an actual number here because it depends on the size of the circle that I gave you. Okay, but what I want you to add here is that this is going to be true, okay, that you will have 1 radian be the size or the angle that we measure if we have a central angle. Okay, back in geometry, we know the measure of this angle was equal to the arc length if it was a central angle. But that's not the case if, say, we have an inscribed angle. This angle is not the same as that arc length. This is bigger by a factor of 2. Okay? But we're just going to focus on central angles in this class. For these ones, we're talking about how many pipe cleaner arc lengths. If you got an angle between 55 and 60, it'll fit a little bit more than 3 times in the first half, and then a little bit more than 6 in the total circle. And you were asked to find the circumference based on your number. Again, that will vary depending on what size yours was. But based on this formula, okay, you should have been able to determine a pattern here. If our formula says 2 pi times the radius, and the radius was the same thing as our pipe cleaner, then this literally says we should have 2 pi pipe cleaners fit around our circle. And that as a number is 6 and some change here. That was 2/8. Okay, and then similarly, half the circle would be half of that 2 pi radius, or pi times the pipe cleaners, so that is about 3.14, and similar here. Why this is important is because we're going to talk about measurements on a circle. So I want you to go back here. Just like this 0, 90, 180, 270, we're going to talk about measurements in radians. And if 1 radian is this measurement, and I know that this is 2, 3, and some change, the number pi literally comes from that number of radians, by our definition, in our case pipe cleaners, but the number of radians that fit in half a circle. So this is going to be pi in radians. And then similarly, all the way around, we fit 6 and some change radians, or pipe cleaners. That, by definition, is 2 pi for math. Okay? So going back to this one, your last question was about half of that pi value. It was 1.57. Okay, so half of this pi value is literally 1/2 pi. And so we now know that every quarter circle is worth a half. So there's 1/2, 2/2. This down here would be 3/2 pi. And then we end at the 2 pi. In radians, 0 and will just be 0 regular. And none of these are usually labeled when we talk about the measurement of radians. It's just 0 itself, 1/2 pi itself, and so on. Okay, but it's a radian measure usually when we see that pi. Okay, and then degrees, of course, when we see the degree label. Okay, let's go ahead and actually on the backside do some notes here. Using what we just talked about, we determined that half a circle was 180 degrees, but that was equal to pi. We're going to use this version versus the 2 pi all the way around, even though that circumference is something you're comfortable with. This pi equals 180 is the simplified version of 2 pi equaling 360. Okay, if we just divide by 2 on both sides, we'll use this version instead. Okay, so this is our radian measure, and this is our degree measure. And again, that just says about 3.14 radiuses, okay, radii, fit in half a circle. 180 degrees are in half a circle. And we can use that to figure out what a radian measure is equivalent to in degrees. We know it's 55 to 60, somewhere in that range. So I want you to write 1 radian. And we're going to convert similar to what you did in chemistry if you've had it. If not, it's just a ratio or proportion. You've done this in algebra. You've done this in geometry as well. Okay, so we're going to use this statement here. To get to degrees, we need degrees on top. And to get rid of the radian measure, we got to put pi on the bottom. And again, I told you that this radian label is usually not there. I'm just putting it here so that we see those radians cancel out. So the math for this is literally 1 times 180 over pi. So you're just taking 180 degrees and dividing it by pi. And a whole number, it's about 57 degrees. Okay, so if you toss that on the front side of your circle, it should look reasonable based on what it is. And we know if it's going to fit 3 or more times, it makes sense that it's really close to 60, but not quite. Right. Another thing we're going to talk about later on, but so we don't have to backtrack, is the formulas of a circle. On the front side, you already talked about one of them, and that was circumference. We're also going to talk about area, and that's your pi r squared. For these ones, we won't concentrate in this class on a full circle always. We'll talk about instead just a section of a circle. If I talk about this right here, that's my arc length. And then if I talk about the area of that thing, or the slice in general, that is a sector. Okay, so for this, what we want to do if we have not the whole circumference, but just a portion around, what we're going to do is talk about what fraction is this piece compared to the whole. So to do that, we just have to know what angle is marked off here, either in degrees or now we know about radians, compared to the whole. So we're going to talk about degrees first. So we would just have to multiply this by a fraction. And I know in degrees the whole circle is worth 360 degrees. And we would just have whatever angle measure we're working with on top. Okay, but we could also talk about this same fraction in radians. And all the way around in radians is 2 pi, just like our circumference formula. Okay, same thing over here, area. If I'm talking about the area of the sector versus the arc length, we just have to times it by the fraction that we are working with. So theta over 360 or times theta over 2 pi. And we'll practice using those. Okay. We're just going to do some conversions to start with here. So just like up above, we're going to make a little table here. We're trying to get rid of degrees to get to radians. So that means pi has to be on top, 180 degrees on the bottom. Okay, and if you can reduce in your head, it's going to save a little bit of time here. 3 over 18 is 1/6. Tack on your pi. We're not going to use the approximate version of these. We're going to use the exact value, keeping pi in our answer. Okay. You may or may not have seen a negative angle before. I want you to add this note here. A negative angle measurement just represents an angle measured clockwise. Okay. When we're doing the instructions for that activity, you were asked to measure your angle going counterclockwise, and that's standard. Okay, so if you see a negative, it just means go the other direction. It doesn't change our math here. We're going to times by pi, divide by 180, and your answer is just going to be negative. Okay? If you aren't sure what this fraction is, which may not be as obvious when we're dealing with 45, toss it in your calculator. It is negative 1/4. Then tack on the pi. So don't type pi in, just the other stuff. Okay, so here the same thing. Okay, hopefully you're getting we're really just dividing by 180 and putting a pi on. Okay, so here again reduces with 1/4, 5/4 pi. Okay. Last one, reducing 12 over 18 is 2/3, and then pi. The next one's very similar. I'm going to show you the first one, and then I'll set you free to do the rest of them. Okay, we're still creating a little chart here, but this time we have radians and we're trying to change to degrees. So that means our degrees has to be up top, and then our radians on the bottom. When we have something on top and bottom, they cancel out. That's like saying pi divided by pi, which reduces to 1. So we really just have to take 3/4 of 180. Okay, so again, for this one, 180 divided by 4 is not necessarily obvious. Necessarily, so you can just toss that whole thing in your calculator, but this is 135 degrees. Okay, I want you to pause the video and take care of those last 3 for me. Okay. On this one, another thing you can do with these ones, we are saying that pi is equal to 180. So really, we can substitute this 180 degrees because the pi's cancel if we see a pi. So just take 5/6 of 180. Okay, simplify that. Same thing here, 5/3 of 180 and of that pi. Okay. What I want you to do is compare all your numbers here to answer questions 3, 4, and 5. Okay, because it says, what do you notice about these things? Okay, so pause the video again real quick to do 3, 4, and 5, then we'll finish the rest together. So for these ones, hopefully you notice the 45 measures had something with a divided by 4. Okay, but it's really something pi over 4. And multiples of 60 was something pi over 3. And multiples of 30 were something pi over 6. And this just goes back to, we know this is 180 degrees. 180 over 4 is 45. 180 over 3 is 60. And 180 over 6 is 30. So if it's a multiple of 45, it's just how many times we're multiplying that with that fraction. Okay? So now we're going to do some applications with those formulas that we talked about. So circumference and area, but we're traditionally not going to be working with a full circle. It'll just be a section. So it says an ant is walking around the perimeter of a circular wreath with a radius of 8 inches. And we want the ant to walk 21 inches and determine how many radians the central angle is that intercepts the path. Okay, so here I'm going to do a visual for this one. We know our radius is 8 inches. And we know the ant walked 21. Remember, the arc that is 8 for us is about 57 degrees. So this right here, okay, we're measuring out at 57 would be 8 inches. That's the definition of a radius, or a radian, excuse me. So then 21, I would get through one, I'd get through another, but I wouldn't quite get to a third one. So I'd end up somewhere over here. Essentially, I want this angle in terms of radians, not in terms of degrees. Okay, so and you may be able to see the pattern and know that relationship, but we're going to talk about the math for it as well in relation to the formula. And in this case, since it's related to this perimeter, the outside arc, it goes with our circumference. Okay, so that's our 2 pi r. And since it wants radians, we're putting that over 2 pi. In general, when you're working through these formulas, you want to simplify before you substitute values in. So here, those 2 pi's will cancel. And then we know they're going a total of 21 inches. We know our radius is 8 inches. And we're multiplying it by that angle. Divide this 8 over. And our radian measure is 21 over 8. And again, this label of radians is not often there. But I want to talk about this. Remember, this was 1 radian. Then this was another radian, and this was a little bit more. So this 21 over 8, if you put it in your calculator, if you just think about it as a mixed number, is 2 and a little bit more radians. Okay, so if you can see that from a picture or visual, you don't need to use this formula. Okay, but this is what we're most comfortable with, so I'm always going to relate back to that. Okay, now we're going to work with a sector of a central, with a central angle, but this time it's going to talk about area. Okay, so I'm going to jot down my area formula. Okay, we know it's going to be times something, but we'll come back to what. So it says sector has central angle 2/3 pi and an area of 25/3 pi square feet. What is the exact length of the radius? Okay, so area formula came from this. And what you're going to decide this part on is whatever your central angle is measured in. So if you see central angle with the degrees, then we're going to use 360. If you don't see degrees, you're going to use 2 pi. Okay, so in this case, it had a pi on it, but I'm telling you, no matter what, this didn't have a pi on it. It was still a radian value. Okay, so no matter what, if it doesn't have degrees, it is radians. Okay, so we're putting 2 pi and then our theta. Okay, we're writing the regular formula first because it's going to help us simplify before we plug in values. So here we still have pi's that can cancel, just not the 2. But here's the thing. This theta over 2 right now, if I put this 2/3 in, it's going to be a fraction over a fraction. So we want to avoid that. So we can fix this by saying instead of theta divided by 2, we can call that 1/2. And then bring down the rest. So if you want to keep theta with it, you can. And just chuck that r squared to the side. The order of these 2 items does not matter. But now we have something we can plug in with no problems here. So area was 25 over 3 pi. 1/2. Theta is what we're solving. Or no, excuse me. Theta is our 2/3 pi. And then our r squared stays r squared because the radius is what we're solving for. Okay, I'm going to let you practice your algebra skills here, so pause the video and go ahead and solve that one. Okay, here you can cancel these 2's because they're next to each other. 1/2 of 2/3 is 1/3. You don't necessarily have to start with that. And I've got 25/3 pi equals pi over 3 r squared, or 1/3. Okay, very similarly, we can cancel out those pi's. Okay, see it, same place on both sides. Now I have 25/3 equals 1/3 r squared. Multiply by 3, and I get 25 equals r squared. R is 5, and we want to make sure we get that label of feet on there. Okay, area is feet squared. Everything else gets the regular label. Okay, number 8 is similar process. You're missing something. Okay, we've got the arc of a circle with radius 5 feet and a length of 25. Since it says arc length, that's a circumference problem. And again, we're going to keep reading to decide what's going to go on with our fraction, theta over 360 or theta over 2 pi. So it says the radius is 5 and that's our length, but we're supposed to find the measure of the central angle. And I want it in both radians and degrees, which technically means we could use either piece here, the 360 or the 2 pi. Okay, once we find one, we'll just convert to find the other, so we're not going to use both formulas, save ourselves some time here. Okay, but in this case, I want you to think about what would make your life easier rather than just using degrees because you're more familiar with it. In this case, if I put 2 pi here, That makes my life easier because now my 2 pi's go away and I don't have as messy of a fraction, okay? So here, if we sub stuff in now, the arc length was this, so that's our c value. And then the rest, the r theta, comes down. Our radius was 5. We just have to move that 5 over. Okay, again, think before you do. If I have this divide by 5, that's a mess. Okay, so try to avoid those fractions in fractions. We're going to instead multiply by the reciprocal and then do some simplifying here. So theta equals, those 5's cancel to 5 over 8. And you can just toss this part in your calculator if you want. Just don't forget pi stays out because we want these in exact values. Okay. All right. Once we have that, that's our radian measure. Now we're going to just change it to degrees. Remember, this pi is the same thing as 180. So you just have to take 5/8 times 180. Okay, because your pi's cancel out. And then that's 112.5. Okay, same angle, different ways to write it. Last problem is a bit of a weird application, but it's one of the reasons we use or talk about sectors. Okay, it says here we've got Grand Rapids, Michigan with a longitude of 85.67 degrees west, latitude 42.97 degrees north. And then Louisville, Kentucky has a longitude very similar here, and then a latitude of 38.25 degrees north. Because those longitudes are so close, we're going to essentially ignore them, assuming that Grand Rapids is directly north on a map of Louisville because they're very close to directly north of each other, and just focus on their distance away the other direction. Okay? So with that in mind, what we're going to do is draw out a piece of the world. Okay, so we know the Earth is round. We're going to have this curved section to talk about the distance between our 2 cities. So Grand Rapids is above or more north of Louisville, so we'll draw it like that. And then this is the edge of the world, so our sector is going to actually go inside to the center of the Earth. Okay, and they tell us the radius of the Earth is 3960. Okay, what we're asked to do is estimate the air distance, meaning this distance along the curve, assuming we're not taking all the weird turns, okay, just the air distance, shortest distance between them, based on just this sector. Okay, so in order to do that, we need to know this angle, and that's where those latitudes come into play. Okay, latitude is measured from 0, and it's a spot in the middle of the ocean, but we only care about the distance between them. So we're going to find that angle just by subtracting them. And I want you to write this down so you don't forget what happened in this step to find the value. Okay, and that was 4.72 degrees. Okay, from there, we're good to solve because I have all the pieces I need to find this arc length, which relates to circumference. So circumference is 2 pi r times the angle over, in this case, we're talking degrees, so 360. Always try to simplify before. Okay, in this case, you can simplify here and just call it 180. We don't need to worry about this fraction, though, because if we imagine plugging that in, 4.72 over 180, there's not a fraction inside of a fraction for us to worry about. Okay, so everything comes down. The radius was 3960. And then we have 4.72 over 180. This is something we put the whole thing in the calculator, including pi, because it's an application. We don't want to say it's so many pi miles away. We just want to say so many miles. Okay, so we're going to put the whole thing in, just like you see it. And because your homework asks you to round to whole numbers, we're going to do the same thing. Oop, I missed here. That was divided by 180. So about 326 miles. Okay. If you have any trouble on your homework, please come see me and get in the habit for this chapter, especially since all this stuff is brand new, to be checking your answers regularly.